Hello and welcome to this exciting video in chemistry. So this was a suggestion. Someone wanted me to explain to them about excess and limiting reagents. Okay, so I decided to make a video so that everyone can learn and benefit. So in this particular video, I have a question from 2019, which is science paper 2, and this is question B. So according to the question here, we are told that 600 grams of magnesium oxide reacts with 980 grams of dilute sulfuric acid as shown below. So you have magnesium oxide, dilute sulfuric acid. This gives us magnesium sulfate and water. Okay. So the first question here says that determine the limiting reagent in the reaction above. Okay. So when we look at this reaction, we need to find the limiting reagent. Okay, and this is very simple. Okay, I like to tell myself that something is simple even before I answer it, so that the brain can relax. Okay, whatever you tell the brain follows the instruction. So when you say something is simple, your brain automatically relaxes. So this is a very simple question. So determine the limiting reagent. Now, what is limiting reagent? First of all, what are reagents? Reagents are two substances that are reacted together. In other words, these are the reactants. So the other term here you can find is reactants. Okay, reactants. Okay, so between these two, there is one that is added in few amounts and one that is added in greater amounts. Okay, so the one that is in less amount, it is called the limiting reactant. But then that's not the correct way of thinking about these things. When we look at the limiting reagent, it is simply the reactant. So we have reactant A, which is magnesium, and reactant B, which is sulfuric acid. So I think of these things like this. The reactant that will finish faster when the reaction is going on. Because you can see from here that dilute sulfuric acid looks to be more compared to this. But then when the reaction takes place, you can find that this finishes faster, or this may finish faster. So the way to think of limiting reactant is that reactant between A and B, which runs out, finishes much quicker. Because if magnesium finishes, the reaction will stop. So the limiting reactant controls how long the reaction will take place, because once it finishes, the reaction will stop. Okay, so determine the limiting reactant. Okay, so I'm going to explain how we can find this. So we are taught that for magnesium, it is what? 600 grams. Okay, I'll write it here. 600 grams magnesium oxide. Sulfuric acid is 980 grams. Okay, so now here's how we are going to find this question. Okay, so let me prepare my calculator and everything. Okay, so we're going to find this question like this. Okay, so the first, so it's the solutions here. All right, so the first question wants us to find the limiting, okay, the limiting what? The limiting reactant, okay, and this is how we are going to find the limiting reactant. So question A, you're going to find the moles, okay. You're told that magnesium has a mass of 600 grams, 600 grams, while sulfuric acid has a mass of 980 grams. Okay, so now we need to find the moles. So I like this formula: mole is equals to mass over the molar mass. Again, here we're going to say mole is equals to mass over the molar mass. Now, what is the mass for MgO? We are simply told it is 600 grams. Now, what is the molar mass? So we're going to say magnesium oxide. Oxygen, you only have one molecule times the mass number. You just look up this at the periodic table. The number on top of oxygen is 16. Magnesium, it is 1, and the mass number happens to be 24. Okay. Then here you do this. This is 16. This will be 24. Okay. And what you get here, you get, this is 6 plus 4, that is 10. 0 carry 1, 2, 3, 4. So you get 40. Okay, so we get 40 grams. So 600 divided by 40 grams per mole. These are the units for molar mass. So here we have the moles, and these moles are for MgO. It is 15 moles. Okay. Then we find the moles for sulfuric acid. The mass is 980 grams, or to be the molar mass. We do the same thing. H2SO4. So you have 4 times 16. Okay, what do we have here? So 4 times 16, this is 64. Sulfur, you have 1 times the mass number is 32. You get 32. 2, the mass number for hydrogen is 1, so you get 2. Okay. So 4 plus 2 plus that will be 8 and 9. Okay. So it is simply 98 grams per mole. Okay. Now we have to divide that. Okay. We need to divide that. So you're going to have 980 divided by 98. You get 10. So here you get 10 moles. Okay. Now, after finding the moles now, okay, so these are moles for what? Sulfuric acid. Okay. So the step is very simple. Just find the what? The moles. Okay. So we'll find the moles for magnesium oxide and the moles for this. Now, so the question here was saying that determine the limiting reagent. Okay. Now, before we determine that, first thing that we needed to do is first to check if the equation is balanced. So I have 1 atom of magnesium. I also have 1 atom of magnesium. So magnesium is balanced. I have oxygen 1, but then I have 4 other oxygen atoms here. So 4 plus 1, that is 5. So if I have 5 oxygen atoms here, I should also have 5 oxygen atoms. 4 plus 1, 5. Oxygen is also balanced. 1 atom of sulfur, balanced. 2 atoms of hydrogen, balanced. So in this case, it means that here, just for the sake of understanding, though you're not supposed to do this, just for the sake of this question. So here we don't balance anything. So it means that there's a 1 here, there's a 1 there, there's a 1 there, and there's a 1 there. Okay. Now we need, so these numbers here that we always put in front, we call them, they are called coefficients. But here we did not put them. So if they're not there, it means there is a what? A 1. Eh? So the coefficient of magnesium oxide is 1. The coefficient of magnesium, sulfuric acid is 1. The coefficient of magnesium sulfate is 1. And the coefficient of water is 1. Okay, because the equation is already balanced. So to find the limiting reactant, or the limiting reagent, divide the moles by the coefficients. Okay. So here is what we are going to do. So magnesium, the mole, it's 15 mole over what? The coefficient, the number which is in front of magnesium oxide is a 1. Okay, so it is 1. And what do we get here? We get 15 moles. Again, the mole for sulfuric acid is 10 moles. Okay, and over 1 we get 10. Okay, so this question was easy because it was already balanced. So now this is where now you compare. So from here, what we can see, there are more moles of magnesium oxide than there are for sulfur. So what's the conclusion here? The conclusion here is that the limiting the limiting reagent is this one, which has 10 moles, because this is less compared to that. So it's sulfuric acid. So you've seen how these things are, but when you compare from the masses that were given, sulfuric acid looks to be more because it is 980, which is far much greater than 600 grams. But then it is a limiting reagent because the moles here have shown, okay, after we divided them by their coefficients, it has shown that it is the limiting what reagent. Okay, so this one is the limiting reagent. Okay, go back to the equation. So this is the limiting reagent. Okay, limiting reagent. Now what is this? This is called the excess reagent. Okay, so the one which is not the limiting reagent is called the excess reagent, just for the sake of you knowing it. Okay, so after you found the limiting reagent, now you can proceed to the other questions. Question B says, calculate the mass of magnesium sulfate that was obtained at the end of the reaction. Okay, so here now we need to find the mass of what? The mass of magnesium sulfate that is collected at the end of the equation. So we need to find the mass for this. Okay, now the mass that we are finding for magnesium sulfate here, we are using the equation. Okay, and when you use the equation, the mass that you are finding, it is called the theoretical, because here this is called the theoretical yield because you haven't yet done the experiment. Here you are just telling yourself, okay, as a chemist, a scientist in the chemistry laboratory, you've gotten 600 grams of magnesium oxide and 980 grams of dilute sulfuric acid. After you do the equation, you've discovered that this one will be the limiting reagent. Now you are asking yourself, how much of this am I going to get theoretically? So what you're going to do here, you're going to do what we call the mole ratio. And here is what we are going to do. We're going to do what we call the mole ratio. All right, so here we are. We need to find the mass now, okay, for this guy, magnesium sulfate, okay, the mass. All right, so from our previous question, we are just from seeing that the limiting reagent is actually dilute sulfuric acid, and we said this equation is already balanced. This simply means there's one here, there's one there, there's one there, and there's, because we don't need to put anything here. So those are the coefficients there. So now to find the mass here, you do what we call the mole ratio. You do what we call the mole ratio. The mole ratio is just a comparison. Okay, it's a ratio, basically just a comparison between a reactant and the product whose mass you're finding. So we can use any of these to determine the mass here. But since we know the limiting reagent, it is the one that will control how much of magnesium will be formed, because it's the one that finishes fast. Okay, so for this one, we are going to say, just to put what I've said here, you use the limiting. So it's the importance of you knowing the limiting reagent. You are supposed to use the limiting what? Reagent. Okay, so one that will control. So we are going to do mole ratio for what? Sulfuric acid. We compare it to magnesium. Okay, what are the coefficients here? So the first thing that will go here is coefficients. What are the coefficient here? Coefficient is 1. Coefficient there is also 1. Here, what are the moles for sulfuric acid? We calculated that to be 10. So we're going to say 10 moles. So here it's the moles that come. Then here you put X, you don't know, okay? You don't know the moles for this. You do mole ratio 1 times X. This will give us X. and 1, so this is 10 moles. So you've now find the moles for magnesium sulfate. Okay, so after finding the moles, now it's easy for us now to find the mass. Okay, so the mass is just equal to mole times molar mass. In my previous video I explained how this formula comes about. Okay, so you should watch my previous video. I was doing a similar question and the percentage yield, and this is where we're heading to in this question. Okay, so the mole, 10 moles, the molar mass for magnesium sulfate we need to calculate. Okay, as scientists we always have to calculate everything that we are doing. So magnesium sulfate, so you have 4 times what? The mass number of oxygen is 16. Okay, 1, the mass number of sulfur is 32. 1, the mass number of magnesium is 24. Then what do we get? You get 64, you get 32, you get 24. Here you just need to add. So please solve with me. Don't just be watching, solve as well, so that sometimes we make errors, and we are depending on you to correct us if we've made an error. Okay, so 64 plus 32 plus 24. Here I'm getting 120. Okay, I hope that's correct. 120. Okay, so here we did 4 times 16, 64. Okay, so 120. These grams per mole, these are the units for the molar mass. Okay, so we're going to say 120 grams per mole. All right, then we just need to multiply this, and here what do we get now? We are going to get 1,200 grams. Okay, so since we've calculated this using the equation, we haven't done the reaction, because you're supposed to do the reaction and then you weigh how much of this you're getting. You need to weigh how much of this you're getting. But here we are just using theory, our understanding of more concept. So this mass, it is called the theoretical yield. You might be asked to find the theoretical yield. Okay, that's the question here is done. 1,200 grams. Okay, 1,200 what? Grams. Let me write that nicely. Okay, so let's go to the other question. So the other question says 1,080 grams of magnesium sulfate was obtained. Now this is after the experiment is done and you weigh how much. So after weighing, it was found that the actual mass actually is not 1,200, but the actual mass obtained from magnesium sulfate is actually 1,080. So the question now will say, calculate the percentage yield. Okay, calculate the percentage yield. Here is how we do it. Okay, so we're told that actually this, after the experiment was done, it was found to be 1,080 grams. Now this is now the actual yield now that you get after the experiment is done and you weigh the thing. So theoretically we had calculated it that it's supposed to be 1,200 grams, but then the actual one is that. So usually the theoretical yield must always be more than the actual yield under normal circumstances. Okay, so here is how you find the percentage yield. So you're going to say percentage yield is equal to actual yield over theoretical times 100. So the actual yield is 1,080 grams over the theoretical yield was 1,200 grams times 100. Then we solve this one here. It's just going to be like I said again, please solve with me. As we are solving here, I said we might make some errors that you can point out. This is what happens in class. If the teacher makes an error, you raise your hand. So I didn't understand there. Is it this? And then it's corrected. But then this is a video. There's no one to correct me. I'm just alone recording this. So make sure you are also solving so that we see. Okay, so times 100. Okay, so here from me, I'm getting 90%. Okay, that's my theoretical yield. Okay, so let me know if you have any questions in the comment section. This was just a suggestion. Somebody sent this question to me to solve for them. So I hope we've learned something here. We've learned on percentage yield, limiting reagents, okay, excess reagents, and just everything. So please hit the subscribe button if you're not subscribed. I really need your support. Also like and share, leave a comment if you've enjoyed the video, and also for those that would like to join our team, SmartNets team, in our tuition center online, you are free to join us as you prepare for your exams. Okay, so see you in our next video.